Hello everyone, warm welcome to this webinar to present the SESAR validations for multiple remote towers and automatic speech recognition. We have a tight schedule and an exciting program for you today, so we'll start right away. This is a webinar that follows a physical open day we had in Norway last November with more than 70 attendees. It was just before society closed down again, but we were lucky to have so many people here in Norway. Still, there were many that couldn't attend that webinar, that physical open day. So we were asked to hold a webinar, which we do today. There are nearly 300 people registered for the webinar today, which is really exciting. And we have a very good program for you today. So good morning, good day, or good afternoon to you, wherever you are in the world. This is the agenda we have. We will start with a short introduction by myself. My name is Mrtm. I work in product management within Indra. Then we will have some perspectives on multiple remote towers from our partners Avinor and Hungaro Control. We will then go into ASR, which is automatic speech recognition, presentation by György Balog and Viktor Horvat, and some video demos. Then we'll talk about the PJ05 validation platform with the video demonstration, and then we will hear about the execution of the validations. You see that we have a Q&A at the end of the webinar today. At the top of the HMI on your screen, you can find an icon with a bubble question mark, which is a Q&A icon, and it's possible to write questions to our expert panel. Some questions may be answered in writing during the webinar, or some questions will be answered during the Q&A session at the end of the webinar. These are the experts that will present to you today. We have Jon Are Pettersen and Tristan Blank-Brud from Avinor. We have Csaba Gergely, Viktor Horvat, and Fanny Kling from Hungaro Control. And my colleague György Balog and myself, Mrtm, from Indra. So I'll start right away with some introductions and background for these validations. SESAR is a big resource program doing research and development within Europe. There's a lot of projects going into air traffic management programs within SESAR, and the validations we have done is within PJ05 digital technologies for a tower. Within PJ05, you can find two solutions. Solution 35, multiple remote tower and remote tower center, and solution 97, which again is split into two. Solution 97.1, virtual augmented reality applications for tower, and 97.2, which deals with automatic speech recognition. So the two validations we have done so far, they deal with solution 35 and solution 97.2. So what is a multiple remote tower? Remote tower in itself has been around for a while, and we see that in operations many places in the world. But so far it is mostly single remote tower, that is a single controller with one airport. But multiple remote tower is looking at the ability for one controller to operate several aerodromes simultaneously. And then we mean simultaneously at the same time. You can have landing on one airport while you have a departure on another one, and some taxiing aircraft on the third one. So it's really in parallel. And to be able to do that safely, of course, we have to go through validations like the validations we do in SESAR in an operational context. We did this in SESAR Wave 1 2 years ago, but now we also extended it with dynamic allocation. And that means that we are looking at the remote tower center with multiple airports, with multiple controllers and multiple working stations, and how you can allocate aerodromes to workstations according to the workload and the traffic demand for those airports, and then change and move an airport from one controller to another when that's needed. So this is the dynamic allocation of multiple remote tower. I mentioned that we did some of this work during Wave 1 2 years ago, But now in wave 2, SESAR PJ05 wave 2, we have this solution 35 with 2 objectives. The first objective is the multiple remote tower planning tools for Supervisor, and the second one is the dynamic allocation of aerodromes. So there are 2 focus areas here. Dynamic allocation, as I mentioned, how can you put aerodromes correctly into controllers in a remote tower center, but also looking at how a supervisor can help in this context. We have operational supervisors in large airport towers, and we have supervisors in area control centers. But supervisors for a remote tower center is something new, and we need to look at how the roles and responsibility can be in that context. So this is one of the validations we've done, and the other one about solution 97.2 is about automatic speech recognition. This is a technical validation, while solution 35 is an operational validation. So this is looking more at the technology and how automatic speech recognition can be of help to the controller and how we can use it. Victor and Georgi will tell you more about that in a few minutes. So we've done 2 validations periods so far. In September 2021, we had the validation with Avinor, focusing on solution 35, the multi-remote tower. That was a real-time simulation where we simulated 4 aerodromes by using a simulator system from Micronav, the best simulator. And then in November 2021, we had a similar validation with Hungaro control, also using a real-time simulator and the same setup as we did for the first one. But in this validation, we also included solution 97, the automatic speech recognition. The Avinor validation took place 3 weeks during September 2021. And the focus was on air traffic controllers and supervisors. We had 6 Outgos and 6 supervisors attending during those 3 weeks. And there were people with experience from large tower and small towers, and supervisors with experience from towers and air traffic control centers. So we simulated up to 3 aerodromes simultaneously and at one working position. And we looked especially at how we could move aerodromes between the working positions, both planned and unplanned in the event of emergencies or equipment failures. For the Avinor validation, we also looked at how we could combine tower and approach in a multiple remote tower setting. Then in December, we had the Hungaro control validation, where we had 2 weeks in November 2021. This was in the middle of COVID situation. So we were able to conduct 2 weeks with 2 fully used RTMs. We used up to 4 aerodromes at the same time, but 3 maximum at 1 MRTM, multiple remote tower module. Here we attended with 6 Outgos and supervisors, and there was a full rotation of tasks, so everyone tried the different positions and also the supervisor position. Again, we tested the dynamic allocation with planned and unplanned handover, and also dealt with emergencies and equipment failures. And in this validation, we included the automatic speech recognition. I'll show you now a short video about the Avinor validation and how that was conducted.
We live in a digital era in which we quickly adopt new technologies to make life easier. Yet manual processes and visual observation, looking out the window, are still crucial for air traffic services at most airports. At Indra, we believe in progress. To improve efficiency of service, the Innova Tower System allows air traffic service officers to manage several airports from a remote location. Situational awareness is ensured by having all information and control systems integrated into a single user-friendly display. As part of an EU-funded SESAR project, Indra and Norwegian air navigation service provider Avinor have collaborated on research to further improve cost and operational efficiency. Avinor uses the Innova Tower system for remotely managing airports in the world's largest remote tower program. Together, we have successfully validated dynamic remote towers, allowing flexible allocation of airports between different working positions.
In 2019, we validated that one air traffic controller can manage up to 3 airports from a single integrated working position. Now we've taken it one step further. We allow controllers to move control of airports to different working positions. If something happens so you need to focus on a single airport, you can transfer the other airports to your colleague. This brings a new level of teamwork and operational flexibility to air traffic management.
During this validation, we have simulated the operation of 3 airports from one single working position, but we have also introduced aircraft emergencies and bad weather conditions, and we have also focused on the transfer of airports from one working position to another, and included in that the supervisor role in the control room. The experience is that it's good to integrate all the functions into one single working position and to have all the functions that's needed for the controller. That also helps us in organizing the service provision in the future.
Like many other countries, Norway has a lot of smaller regional airports. They're operated by 2 to 3 controllers each. If we can do that in a remote tower center, where one operator can operate 3 airports, 3 operators can operate 9 airports, we can get a more flexible service, cheaper service, and not to forget that the work satisfaction per controller, each controller actually will increase massively.
The future is here. Embrace the progress.
There we are. Then we will continue to hear from Avinor on their perspectives on multiple remote tower. So I give the word to Jon Are Pettersen, Program Manager of the Avinor Remote Tower Program.
Thank you, Martin. Let's then just start the presentation here. Yes, my name is Jon Are. I've been working with this program now for the last 6 years. And I'm going to give you a perspective on the remote tower program and multi especially. So the journey that we have started on is really to get from a traditional tower with legacy system and then moving that service over to something that looks like this. And this is really a journey not only to do remote, but as this SESAR exercise is all about, it's to get eventually to the multi use of the remote tower system. And this is much more than just replacing the out of the window view. If we were to take the existing tower systems and take them over to a remote situation, just putting cameras to replace the out of the window view, we will not be able to move to multi. The original tower concept do not adapt to multiple operations, at least not the ones that we have today. So with the remote tower program, we both needed to get remote, but also we needed to do what's necessary to eventually get to multiple, and that means also changing all the ATM systems so that we could eventually then take multi into operation. So why are we doing this? And as also mentioned in this video, there are 2 main drivers for this from a business perspective. We have a lot of old tower installations They are from the 50s, 60s, and they really need to be replaced, and it's quite costly to build new towers. So we had a large upcoming investment in the existing towers. But we also see that a lot of these towers have not much traffic, and we could reduce the operational cost by introducing multi. This could also give us a more flexible service delivery to the airport customers and also increase the readiness when needed, for instance, for ambulance flights and search and rescue. And the enablers for this is, of course, then to go digital. With digital solutions, we have fewer buildings, we have less to maintain, but also we need to standardize on technology and systems and standardize on operations. This again, we will need the more flexible rostering, and of course then at the end of this, the multi-airport service provision. With the multi, we will get we will reach the goals of reducing the operational costs. Today we have several towers with a lot of local differences, and that gives less efficiency. There's a multitude of legacy systems. These old towers or traditional towers have been built over several years. They are all built with the technology at the time they were refurbished. Some systems have been changed, of course, and are the same in all towers, but each and every tower look differently. And we have a lot of airport-specific differences, and also unit-specific differences. And this also is shown by a lot of different interfaces and HMI, and we need a lot of local training, local procedures, and not two towers are the same today when we operate the towers. Although we own all the towers and we operate most of the towers ourselves, a few is operated by others, but nevertheless they will look different and they do work differently. With remote towers, we remove those constraints. The remote tower program in Avinor, which I will talk a bit on at the end, is about getting 15 airports for the first phase into the remote tower center, the main remote tower center. There we will have 16 working stations, always one in spare, which are all the same. You take out all the old legacy systems, you change both we take all the existing ATM system and consolidate into one screen with one HMI, and it's the same HMI for all the airports. Of course, there's a local adaptation to whatever sensors are at that specific airport and runway light setup, etc. But the HMI, the basic HMI, is the same all over. And especially when it comes to the electronic flight scripts and the surveillance, that will be exactly the same for all the airport. Same capabilities, the same training, the same operation for all airports. And also these working positions in this new center will all be flexible. They are the same. You can take whatever role you like and just log on. There is not so that one specific working position is linked to one tower. This is all flexible. So we're going to start up in single operation in the center, and that's why we have the 16 working positions for 15 airports. But of course, our goal is to then start with 2 airports in multi-operation and then eventually with 3 airports in multi-operation in that center. And with that, we will be achieving cost benefits. To do so, we need to have multiple aerodrome endorsement for each individual working in that center. That we have started already, although multi-software is still a bit ahead of us. We start with the multi-aerodrome endorsements because that will also give us more flexibility in single mode. With the operators having more than one endorsement, we can train, we can plan, we are more robust when it comes to single operation. And it could also be times a day where we could do what we call sequential mode, where one operator could still operate 2 airports, but then only one at a time. But of course, multiple aerodrome endorsements is the key enable for multiple mode. To do so, we will have one unit training plan and as few local differences as possible. That's part of the remote program, is to now make those tower operations as equal as possible. So the same tools, same basic HMI for all aerodromes, and common unit operational procedure as far as possible. Of course, there will always be local adaptations when needed, but if not needed, we will do it the same. Now, so the remote tower program in Avinor is the world's largest remote tower program. We started off and have a mandate of procure, develop, and eventually then install a remote tower system to 15 airports in Norway. And that's including all the needed infrastructure. We're building 2 centers, one main center and one contingency center, all both placed in Bodø. And in 2015, we signed a contract with the Kongsberg Group with Indra Navia as a sub-supplier for the ATM part of the solution. We worked then hard with the suppliers, and in October 2019, we could take the first airport into operation in the contingency center. And a year later, we took 3 more, so all in all, we have now 4 airports remotely controlled from the contingency center. And the picture here is the main center, and that will go operational in May this year. And we hope that we will have all 15 airports by the end of 2023 in this center. The main center, as you saw, is now built. We have set up all RTMs to handle up to the 15 airports. This center is now in the final stage of testing. We have conducted both the FAT and the SAT on the software. We have done the passive shadow mode, and we are now doing the last week of stability tests on the software. So all in all, this center is now ready to be put into operation, and we'll do so early in May. Starting off in single mode, as I said, the position in front here, where people now are just sitting with the laptops, that will be the operational supervisor position. When we go into multi-mode, then we will build up the supervisor position, and the supervisor will have line of sight to each and every RTM and operator within this building. So what we're doing in the SESAR validation now will be the next move in this center, where we then upgrade it, so to speak, to go into multi-operations. A few more pictures from the center. We really believe this center will be a really good place to work. We are able to bring in a lot of people to work together here. We have a strong, hopefully also of good discussions among the workers, and we will be able to build a much more flexibility and robustness into the operation in this center than what we have today in the individual towers. So all in all, we are looking very forward now to the next step with the multi. We're running forward with the single operation that is looking really good, standardizing, preparing for multi, and then exactly when we will start with multi-operation will depend on the both readiness of the software and also the approval of the authorities. But we are moving forward, and eventually we will be able to run all the 15 airports in multi-operation from this site within hopefully not too long. So thank you for your attention here, and of course I will join further on to be able to answer any questions you have. So Martin, back to you.
Thank you very much, Jon Are. Very excited to see the center and the large operations. I believe this is the world's largest remote tower project at the time. So it will be interesting to see when multi also can be taken into use here. Then we're going to move on. I should mention that I forgot to mention that the webinar today is being recorded. We haven't already decided whether that can be made publicly available due to GDPR and other reasons, but we'll see how that is. But we are recording the session today. The next speaker is Csaba Gergely from Hungaro Control. Hungaro Control has been operating a remote tower for a long time, and Csaba is a senior advisor ATM. You can take over, Csaba.
Thank you, Martin. Good afternoon, ladies and gentlemen. I'm trying to share my screen to you. If I can do that, then you will be able to see my screen. Yes. So, welcome from Budapest, from Hungaro Control Headquarters. I will give you a short summary of what we did in the past years within the SESAR activities regarding multiple remote operations. As you can see, Hungary is a small country in the middle of Europe, and although we are a small country, we don't have as many airports at the countryside as other countries have, but still we have some, and a few of them with international traffic, scheduled traffic. Therefore, always been a willingness from the government to serve these airfields by air traffic control service to provide. However, due to the very low amount of traffic, it was not financially feasible so far. Therefore, we still trying to find the correct way to provide service for these small airfields. As you can see on the map on the left-hand side, we have a quite small, tiny white spot south of Hungary, where we are providing the ATC service for the upper airspace for Kosovo from Budapest. So we now do have a remote airspace, and also we do have, as you may know, a remote tower for Budapest Airport itself. On the right-hand side, you can see some numbers in a nutshell, and of course these numbers are prior COVID numbers. Back in 2019, we had these numbers for our traffic. We have a strategic program for implementing remote tower service, and the first stage for Budapest Airport, which installation was going live back in 2016, and since then we gathered quite a lot of experience in different conditions, different weathers, different traffic situations. And now we have gathered more than 3,000 live hours controlled from our remote tower installation for Budapest Airport, which is still single and one and only live installation worldwide, serving dual runway, medium size and traffic volume airport. Most of the operation from this facility was in good visibility conditions using the cameras, because in low visibility procedures there is no need to use cameras, as you don't have a visual control for the traffic. Most of the time we had dual runway operations, which made the work more complex and increased the workload for the controllers. We do not have too many VFR traffic, and therefore the system itself was focusing and designed to serve IFR traffics. That's what we have mostly at Budapest Airport. During these hours, we had emergency situations on hand and served perfectly. We had many training flights, especially during the low traffic volume periods last year and this year in the COVID situation. And also we are facing almost daily with different airspace and airport taxiway runway closures, which also increases the difficulties for the controllers. But so far, all the operations went smoothly and safely. Multi-remote operation. Back in 2017, we started to deal with multi-remote operations within the SESAR PJ05 project. At that time, we've been participating in cooperation with Frequentis and DLR. We had this live simulation in Braunschweig at DLR, including 3 airports from Hungary. One was Budapest with a simplified configuration, and we've chosen just one runway of Budapest Airport. The other was Debrecen, which is located eastern of Hungary, east bank of Hungary, and the other one was Papa, which is a military airport. So these different style and different traffic volume airport were chosen intentionally. And of course, at Budapest, we had the ASMGCS coverage, which gave a lot of extra information for the controllers. And the reason behind was to get an impression how can it be difficult for a controller to handle 3 airports with different level of equipment and different level of traffic volume. At that time, in those days, we've been facing and focusing on the limitations of an air traffic controller. What could be the limitation of the traffic volume, the traffic intensity to be handled simultaneously for 3 airports. And the aim was to reach 3 movements per hour for the 3 airports altogether. And at that time, we did not had special circumstances like emergency situations, but still there were some difficulties during the simulations, which went, I would say, quite smoothly and as expected. So therefore we went on with this project, and we made a passive shadow validation at Budapest after installing the camera systems for all the 3 airports and controlling passively monitoring the traffic, not controlling, but monitoring from the centralized controller working position. The lessons learned, the usability, situational awareness, and the procedures. We got a better understanding and better knowledge how these kind of operations with the multi-remote can be increase situational awareness, how and what conditions to be needed for the controllers to handle the traffic safely, and what requirements towards not only the technical system itself, but the procedural and the training side for the human staff to provide the service without any issues and increasing the safety. So last year we went on with this project with in cooperation with Indra, and last November we had a simulation in Asker at Indra's headquarters. We provided the solution 35 with multiple remote tower planning using the planning tool provided by Indra, and we had quite a lot lessons learned during these simulations. The results will be introduced later by my colleague Ms. Fanny Kling. And also we had solution 97 simulation using Hungaro Control's developed, in-house developed automatic speech recognition system, also in cooperation with Indra. And the details of this speech recognition system will be presented to you later by my colleague Viktor Horvat. So we had real-time simulation in Asker last year, and in this year we will have a passive shadow mode validation in Budapest, also using a live camera feed from 3 different airports at the countryside. And we've been installing a controller working position in Hungaro Control headquarters in Budapest. So back to the live simulation details. As Mrtm was mentioning, we used the same installation what Avinor used, but we had our own controllers with the background of several years controlling traffic in Budapest airport. And some of them, they never provided service for small airport with only VFR traffic. So they did not have experience with too many VFR traffic and helicopter movements. But still, all of us successfully managed traffic in the simulator despite the emergency situations and system failures. What was new, the planning functionalities and the supervisor functionalities, as not all of the controllers got the supervisor legislation in the Budapest Tower. So it was quite a new feature. We used the tool developed by Indra. The tool was very supportive, and we gathered a lot of useful information how to manage the allocation of the traffic between the controller working positions, and we got some unexpected results, which will be presented to you by Fanny later. So these were the airports. We had 4 Norwegian airports, which in the initial hours caused some more workload for the controllers, because those airports and the specialties, the local conditions for those airports were quite unknown, but still it was quite easy to get used to the system and to get used to how to handle the traffic, especially for those who attended on the first wave simulations in Braunschweig. So in the nutshell, that was my presentation. and the result you will be get later on from my colleagues. So thank you very much for your attention.
Thank you very much, Csaba. Very interesting to hear. We will now move on to the next part, talking about automatic speech recognition. It will be presented by Georgi Balog and Viktor Horvat. But before they start, we'll show you a short introduction video to this topic, which is a new topic to us and to many, automatic speech recognition in ATC environments. So then I'll switch over to the video again.
Hi Siri, text Mum, I'm on my way. Virtual assistants can make life easier by managing everyday tasks based on voice commands. In air traffic control, voice commands are essential for ensuring flight safety. But unlike the virtual assistants on smartphones, the voice commands need to be manually registered into the tower system. That may be about to change. Indra is working with Hungaro Control in an exploratory project funded by EU's SESAR joint undertaking to develop automatic speech recognition aimed at air traffic control. The goal is to reduce the workload of the air traffic controller. The system recognises verbal instructions related to a specific flight and automatically converts them to inputs to the tower management system. This eliminates the need to manually enter the instructions in the system. The principle is simple. The air traffic controller gives a pilot a command through Indra's Garex voice communication system. A module developed by Hungaro Control interprets the spoken words and converts them into call signs and commands in text form. The text is converted to actions in Indra's Innova electronic flight strip and tower system.
Scandinavian 4558, lineup runway 07.
Lineup runway 07, Scandinavian 4558.
Automatic speech recognition saves time for the controller by reducing manual registration of commands. The controller can focus on more essential tasks, improving flight safety and operational efficiency. North Shuttle 15 Tango Kilo, runway 07, clear for takeoff, wind calm.
Clear for takeoff, 07, North Shuttle 15 Tango Kilo.
The future of air traffic control is digital. Embrace the progress.
Yes, then I'll give the word to you, Georgi, to present more about this area.
Thank you very much, Martin. Good afternoon, everyone. Give me a second to start my presentation. So let me talk a little bit about the automatic speech recognition, which is a part of the SESAR 2020 Wave 2 PJ05 Digital Technology for Tower project. This ASR is a part of the Solution 97 HMI interaction modes for airport tower, and the automatic speech recognition in this solution is supported by AI or machine learning algorithm. This, as it was mentioned earlier, was a technical validation together with Hungaro Control. And the validation platform is exactly the same as what we used in Solution 35. It was a joint validation, but we didn't use multi-setup. We used one airport only. What you see is Budo Airport on the simulator and the Innova heads down. And the validation platform itself, including the ASR module, which is developed by Hungaro Control, and my colleague from Hungaro Control, Viktor Horvat, will tell you some more details about it. It's also including a command predictor, which is an in-house development of Indra Navia, including the Indra Innova Tower system and the Garex voice communication system, and also a BEST simulator. As I mentioned, the ASR prototype module will be described by Viktor. So I would like to talk a little bit about the command predictor. We decided to use machine learning and implement the command predictor. This command, why we choose the machine learning? Because it may improve the quality of the contextual information. Yes, but how can this ASR performance be improved? By assisting the ASR with contextual information about the current flights, uses the experience data to predict the next clearance for current flights. This is what is called assistant-based speech recognition. And how it is worked? Builds the experience by continuously monitoring and logging contextual information like flight positions and destination, the type of flights, clearance is given, or visibility conditions. It uses the prediction to evaluate the plausibility of clearances given by the speech recognition engine, favors recognized clearances with high plausibility, and may reject others. Let me show you some details about the validation platform. This is the Innova heads down, which is including an electronic flight strip, board, and an ASR recognition window. With this setup, we validated different automatic speech recognition use cases. These use cases are the following: highlight of recognized call sign, showing full recognized command on the HMI, manual manipulation of ASR output, and automatic acceptance of ASR output. How we did? Let's see some examples. If you see the frame around the call sign, it shows the call sign highlight, which is one of the use cases. Also, when the call sign is recognized, it's not just highlighting the call sign on the electronic flight strip board, but on the ASR recognition window, the call sign will be presented in front of the controller. Exactly the same how when the clearance is recognized. The clearance is recognized and also the parameter which belongs to the clearance. And if you see the difference, here is the flight is in the airborne bay, but when the clearance is executed, then it is an automatic action without any manual intervention, and the strip will move from the airborne bay to the ground bay because the clearance is executed. Let's have a closer look of the ASR recognition window. This is how it looks, containing some information. As you saw earlier, the recognized call sign, the recognized clearance, the parameter, which belongs to the recognized clearance. In this case, the 07 is the runway direction, but also have some other information. For example, a timer, which counts down for 5 seconds before the clearance is automatically accepted. This is a configuration parameter, so it can be set to any other value. If the controller is not happy with the recognized clearance, then can reject within this 5 seconds. And also, it's possible to accept the clearance within this 5 seconds. So in the next minute, I will show you a short video.
Scandinavian 4573, runway 07, clear to land, wind calm.
Clear to land, runway 07, Scandinavian 45.
You see the call sign highlights.
Scandinavian 4558, taxi to holding point Alpha, runway 07.
Taxi to holding point Alpha for 07, Scandinavian 4558.
Widerøe 864, startup and pushback approved, QNH 1006.
Startup and pushback approved 1006, Widerøe 864.
Scandinavian 4573, runway 07, clear to land, wind calm.
Clear to land, runway 07, Scandinavian 4573.
Scandinavian 4558, taxi to holding point Alpha, runway 07.
Taxi to holding point Alpha for 07, Scandinavian 4558.
Scandinavian 4106, runway 07, clear to land.
Here you will see the the manual acceptance of the recognized clearance.
North Shuttle 15 Tango Kilo, taxi to holding point Alpha, runway 07.
This is a wrong recognition, so the controller rejected.
North Shuttle 15 Tango Kilo, taxi to holding point Alpha, runway 07. Scandinavian 4106, go around. I say again, go around.
And this clearance is also rejected because the aircraft already received the landing clearance, so it was just like a
Scandinavian
example.
4455, startup approved.
It was a very short introduction of the ASR, so thank you very much for your attention. And I will give the word now to Viktor Horváth, who will give you more details about the ASR module, how it works.
Thank you, György. Good afternoon, everybody. I share my presentation with you. I would like to give you a short introduction of the automatic speech recognition, the ASR module that was developed in close cooperation with Indranavia for the SESAR PJ05 solution 97.2. But before I'm doing that, I would like to give you a short background of the ASR development happened in Hungaro control. So we started back in 2018 when ASR technology has been considered mature enough to have ATM specialized focus use case which supports ATM simulations, ATC simulations. And we developed the ASR solution in scope with the ICAO Docker 4444, which is a standardized standard for ATM phraseology. And we have a really ambitious use case for that, the virtual pseudopilot platform. Which it's working in simulations environment. It's really important that it's not an operational environment, and this is a software solution which can recognize the issued command issued by the Outgo. It can read back the command or the response, the readback on frequency, and it can handle data input into the simulator itself. So it is working basically as a pseudopilot, a human pseudopilot, but with the power of ASR under the hood. We have been kept in mind that the human in the loop activity is really important from the point of view of the real-time simulations. That's why we kept supervision interface. We implemented a supervision interface for having human in the loop. Any misunderstanding can happen with the ASR, and these slight misunderstandings can be corrected by humans in the pseudopilot room. So this is the use case that we targeted back in 2018, and the goal was really obvious. It's a cost reduction. It can result a good cost reduction in during different RTS situations like testing. Sometimes we do not need as many pilots as required for a full-fledged simulation during testing, but the pilots usually there, and they are not participating deeply in the activities of the testing. Or, for example, for trainings, we can use this virtual pseudopilot platform. For example, when the radio telephony is the target for the air traffic controller trainees, how to say something on the frequency correctly. So we started the journey to find a suitable ASR technology, and we targeted the IKO hybrid language, which is a kind of English with modified pronunciation. These modifications that you can see is because to reduce the risk of mistakes or switching or misunderstanding letters or words, phrases, which can lead to unwanted situations and problems in air traffic control and, of course, in the simulation, of course. And we identified that the phraseology is based on strict rules. So according to these rules, it can be programmed. In the table below, you can see the comparison between two different ASR solutions. The free speech ASR is really good for natural language processing, and this kind of ASR is usually working online as a cloud service, like Siri or Google Assistant. They are both based on cloud services, and the drawback, the really important drawback, is that they are not adaptable. They are as is. They are created for natural languages, and that's why it cannot be applied to recognize this IKO hybrid language with modified pronunciations here and there. So that's why, obviously, we chosen the predefined vocabulary solution for the ASR, which is great for this purpose. It can operate offline as well, which means it's possible to embed the ASR core into a software solution, and it's fully adaptable. The vocabulary and all the phonemes, which basically make up the words which are spoken. So finally, after market research, we arrived at our current and applied solution, which is Nuance Walk-on Hybrid, and this is a modular and scalable ASR engine. Not just ASR, it also includes a text-to-speech synthesis, so it has the other way around. And this is an embedded solution, and the pre-programmed vocabulary can be extended, and the software itself can be developed around the ASR core through its SDK, powerful SDK for adaptation. And it may sound that we are arrived and this is done and problem solved, but the problem starts here, because we have a really great challenge. The incomplete vocabulary and the inaccurate phonemes can lead to false recognition, and that's why to improve the recognition rate, we have to carefully and extensively prepare this pre-programmed vocabulary and the phonemes, and we have to test throughoutly. And speaking of the ASR module developed with Intranavia for this SESAR solution, here you can see on the right-hand side a block diagram of how the ASR module has been interfaced with GAREX voice communication system and with Innova modular remote tower HMI. So basically, the ASR module receives audio streams from the GAREX voicecom system, and the ASR engine recognizes the speech, and the result then forwarded to the Mrtm with a couple of information about the recognition result. And during this validation exercise, we implemented a limited tower vocabulary because, of course, it was a remote tower exercise. And here are a couple of features which has been introduced. As you have seen it on the video, I think it was really visible, the on-the-fly call sign recognition. So when György started the command, but not finished the command, the system already recognized the track or the flight and the cause sign has been already highlighted and displayed in the SESAR interface also. This module supports a parallel operation for multiple active GAREX channels. We use 2 channels for the validation exercise, but it can be scaled more. And we implemented an extensive logging into the module to ease the way how the logs, I'm sorry, how these logs can be understood, and after the exercise, human factor analysts can see more details about what happened on the frequency. And last but not least, there was a really interesting web-based user interface implemented for demonstration purposes only. So it's really invisible. The ASR in this loop is really invisible. You are not sure what's happening under the hood, and that's why we introduced this demonstration tool to visualize each and every single element of an instruction, and to see what is the recognition rate of, for example, a given call sign of a flight, or the rest of the command and the pieces of the command itself. I would like to introduce you briefly the ASR development team in Hungaro Control, Gábor Kispál and Roland Tihi, who put together this solution, and I would like to give some credit for them. And I would like to thank you for your attention. Thank you, Martin, and please don't forget to ask anything in the Q&A session in the Microsoft Teams. Thank you very much.
Thank you, Victor, and thank you, Georgi. We have already received a couple of questions in the Q&A feed, and we'll come back to that in the Q&A session at the end of the webinar to answer those. So that's a very interesting technology, which is, again, is an exploratory validation. So it's focusing on the technical part and not the operational part in this validation. It's quite early in the maturity process. We'll continue with the validation platform, and I will talk about that. The validation platform, we've seen some examples on it in videos and also in the ASR. And here you can see in this picture from the validation with Hungaro Control that we had 2 multiple remote tower modules, which are called Mrtms. So 2 of those in the validation. Each of them can show up to 3 aerodromes at the same time, and they were fully flexible. So any aerodrome could be shown on any display slots, and also the controllers could themselves select which aerodrome should be in this position. So that's the new thing in this validation, that the dynamic allocation, both by the controller, also between the controllers. Normally the controller themselves select which aerodrome to have, but there's also an ability for the supervisor to do that work. So we have the supervisor position. You don't see it right in this picture, but we have the supervisor position with some tools to assist the controllers in the remote tower center. Here you can see a schematic of the same setup with the 2 Mrtms at the top left and top right, where you see slots for 3 aerodromes on the heads up, the out of the tower window view. And then on the heads down, it's a single heads down screen. So that's an integrated tower screen that provides all the ATM functions that you need for a tower for all the 3 airports on that single screen, except for the voice switch. The VCS is on a separate screen on the side. So we had 2 of those Mrtms and then 1 supervisor with a dual screen and a voice switch on the side. Connected was also 4 pseudo-pilots in another room. They were controlling the aircraft and controlling vehicles and responding as remote destinations, approach or fire service or military or the airport authority in the validations. So that was a part of the simulator to be able to control all this. This picture shows a more overview of the Mrtm, you see the 3 different aerodrome display slots out of the tower views, and then the 43-inch touchscreen in front of the controller on the desk, and the voice switch screen on the side. The heads down screen is a touch screen, but the controller could select whether they wanted to use touch or the mouse on the side there. The voice switch screen is a touch screen. So the out of the window view, the heads up is provided by the Micronav Best simulator. So that provided a tower view for all the 3 airports you can see at the same time. The heads down screen is the part of the Indra Innova ATM system, and this is an ATM system that we provide for operational use, both for small towers and large complex towers around the world. Also, the Supervisor tools is a part of that Indra Innova tower ATM system. The voice communication system used is the Indra Garrex voice switch. And then, as we just heard about from Victor and Georgi, the automatic speech recognition engine from Hungaro Control connected to this. So we've done further prototyping on all these elements to adapt to the multiple environment and dynamic allocation. So when looking at heads up, we have these 3 display slots for the 3 different airports, A, B, and C. And you see that the screens for the A display slot is a bit larger. This is to resemble the implementation Avinor has in Bodø. You saw on the slides and the pictures that were shown by Jon Are Pettersen earlier that they had larger screens. And in the multi-setup there, the A slot will have a 360-degree view, while the B and C slots will have a 180-degree view. In this validation for the simulator, we had a 180-degree view on all the 3 slots. The A, B, C setup is the same on the heads down. So the lower aerodrome A is on the lower, both on the heads up and heads down, the same with the upper left and upper right. The heads down, as I said, has support for up to 3 aerodromes. You see the background is a surveillance picture. These aerodromes that we simulate in the validation, they don't have any ground surveillance in real life, so we didn't provide any ground surveillance in the validation. Most of these smaller airports don't have that, so we only have air surveillance, and we had limited the air surveillance to above 300 feet. But we have the surveillance picture, so all airports had surveillance in the air. We had approach tools for the airport, one airport that we tested combined tower and approach. We have the electronic flight strips on the lower right side of the screen there. We had MET information coming from the simulator. We had the aerodrome selection panel where the controller could select which aerodromes to have on his screen. It could be selected in view mode or in a full operational mode. And then a planning tool, which is new in this multi-setting, planning tool, a timeline for the controller to look at how the traffic develops over time. So if we look closer at this part in the lower right side, which we call the dashboard contains the upper part is the timeline, which is the Outgo planning tool. And the planning tool shows all the flights that are present and in the future as a line in the timeline. So you can see at what times you will have multiple simultaneous flights, and by that get an assessment on the workload you can expect in the future. You have color coding, same color coding as you do in the flight strips to see what's IFR, VFR, arrivals, departures, etc., and get some more information. And the controller can select to what time span he wants to look at, whether it's only the next 20 minutes or whether it's the next 4 hours. The lower part is the electronic flight strip system, and it's divided into 3 here, where you see the 3 airports separately. So we have a separate EFS for each of the 3 airports. And because these are simple airports, we have a limited number of flight strip bays. We have an airborne bay, a runway bay, and a ground bay, in addition to 2 pending bays, pending arrivals, and pending departures. So you see the same color coding being used here, and also for vehicles. And you can also expand these flight strips to get more information on the flights. And the EFS is used to log the clearances given, lineup clearance, clear for takeoff, clear to land, etc. And that will move the strips between the bays. And that was done automatically with the speech recognition, as we saw earlier. So this is the dashboard part of it. The voice switch also supports communication with the 3 aerodromes, up to 3 aerodromes, and voice communication is an important part of this validation, both to see how the communication with aircraft and vehicles is, but also between the airports and use of aerodrome call names in the call signs or in the clearances. The voice switch is also connected to the Innova system, so when the controller selects a new airport into his working position, the voice switch will also be automatically reconfigured, and frequencies and direct access telephone keys will be added for that airport. So it's consistent. All the parts, the heads up, heads down, and the voice switch are configured automatically. The tower, we separated between tower frequencies to talk to aircraft and vehicle frequencies to talk to vehicles. They were separate, and they were also separately coupled in this validation. So we had one coupling group for all the tower frequencies between the 3 airports and another coupling group between the vehicle frequencies. And for the controller, we provided a microphone with 2 buttons. So the upper microphone button, the orange one, then you transmitted to the air tower frequencies to the aircraft, and using the black lower button, then you transmit it to the vehicle. So we wanted to avoid too much pressing and reconfiguring on the touchscreen itself. The controller could press either of those 2 buttons to transmit to either aircraft or to vehicles, which worked very well. And also, of course, the voice switch provided the simulated telephone connections to approach to fire services, airport authorities, military, etc. Then on to the operational supervisor working position. As I said, this is an important part of the validation, a separate objective, as the supervisor role in a multi or in a remote tower setting at all is new. So we wanted to see how that worked and how we could support the controllers in that aspect, but also give the supervisor a way to plan the allocation of the remote tower center. He has to plan which airports to combine to a controller, when to split them, etc. And then he needs some tools. So we have developed through this project some tools to test out in the validations. One is an overview tool, where the controller or the supervisor has an overview of all the airports connected to the center, all the RTMs in the center, and how each RTM are now using the airports. So which airport are now being used in which position, and also by which operator. And you can get some information about the runway in use, the meteorological conditions on the different airports, etc. The supervisor also have the ability to see a surveillance picture, and they can zoom in to any airport to see the traffic around that airport. They can have an alarm list for the center and airports, and also a planning function for the supervisor, which is an extended version of the one we had for the Outgo. So the supervisor is able to see the traffic for all the airports in the center, and can also combine logically different airports to see how that works in the future. So that's a what-if function for the supervisor to see what if I combine these 2 airports or these 3, how will that work out in the future? And then they can plan how to merge or split aerodromes on the RTMs. We have the 4 aerodromes that we simulated in this exercise, but we also added another 11 airports and 11 RTMs into the supervisor position, so that the supervisor was able to work with 15 airports and 15 RTMs to see how that would work. So this was an interesting exercise for the supervisor, and as I said, we had supervisor with experience from A2C centers as well as larger towers in the validations. To provide the out of the window view and also the stimulation to the system, a very important part is the simulator. And we have a good cooperation with Micronav that provide the best simulator for this. They have 2 versions of this, the best tower and the best radar. And in this simulation, we use the best tower, but also the airspace from the radar to be able to simulate the approach functions. So Mrtm has provided the simulators for many years and are based in the UK, providing this for ATM training and validation purposes. Mrtm has also developed and further enhanced the product to be able to support this multi-concept. So the single simulator was able to provide simulation data for 4 airports at the same time. And as you see, we had 3 physical screens showing each airport, and we had 1 computer feeding those 3 screens. And this was with a full 4K UHD resolution at a full 30 frames per second update rate. So it demanded quite a heavy graphics card to be able to provide this level of detail, but it was very helpful. Mrtm made models of all these 4 airports, both the ground space, airspace, but also the 3D view of that airport, to be able to provide as much as realism as possible. In these operational validations, we put the controller in front of the system, and to have the out of the window view with as much level of detail as possible is very important. That gives a more realistic impression. And especially with these smaller airports where we don't have ground surveillance, the visual part of it becomes even more important to be able to visually see where aircraft or vehicles are. And we also put into the exercises situations where vehicles maybe didn't follow an instruction or an aircraft didn't quite respond as expected, to see how that worked in a multiple setting when you have to divide your attention between multiple airports. So the fidelity and of the out of the window view is quite important. And it simulated very well the behavior of aircraft, the vehicles, other ground features, but also the weather situation and light conditions. In one of the exercises with the Hungaro control, we also simulated low visibility procedure settings with a lot of fog and difficult visibility conditions. The interfaces between the simulator and the Innova was multiple. We had Asterix feed to provide the surveillance for all the airports. We had AFDM feed that provided the flight plans for all the airports and all the flights in the airports, and individual feeds that provided MET information. So we also had changing MET, QNH changes, wind condition changes, etc. during the exercises. We also had a scripting interface going the other way so that the Innova system could give commands to the simulator. And that was especially useful when selecting a new airport into the user position, so that the best simulator could then change the out of the tower view and adapt to the correct view. So all this worked very well, and all these exercises were pre-programmed into the simulator so that each controller could have run through the same type of exercise. But of course, there are things happening, and we also had pseudo pilots controlling the aircrafts and responding to the controller's commands. The 4 aerodromes was mentioned earlier. Svartnes in the north, Bodø and Røst in the middle of Norway, and Karmøy on the southwest coast. Quite long distance away, about nearly 2,000 kilometers between south and north. And also a bit difference on the size and complexity of the airports. Bodø is the largest one. In real life, it's about 60,000 movements per year, and mostly IFR traffic, but also some helicopter, rescue helicopter traffic. But as you can see, it's got a full parallel taxiway. So it's all the taxiing can be done on taxiways. Whilst on the other 3 airports that you see here, they have just a connection from the apron to the runway. So then the aircraft had to do a back taxi or to line up and to after landing. So then the aircraft used more time on the runway, which is more complex for the controller because you have to take that into account, the runway occupancy time. So not only the number of movements drive the workload, but also the complexity and the layout of the airports. I'll show you a short video demonstration of the platform and how it was used. And then I'll stop this and I'll turn over to a video. At first in the video, you see a single operation. So we have one airport, which is Bodø, up and running. And you see on the background the aircraft taxiing. And on the heads down display, we have the single airspace. And you can also zoom into an inset window into details. But again, we didn't have surveillance on the ground in the validation. You see MET information on the floating window to the left. And you see the dashboard with the different flight strips. Then we add a second airport, select from the menu, press OK, and then you see the screen splits. A new airport is added on the heads up, and now we have a two airport situation, one at the top and one on the lower. So those are independent. You can zoom in and pan as you like and see the traffic on those two airports. Also individual MET windows where you can open and close. Then we'll add the third one. You see the list here. You can just select it and confirm it. And you see also that you can select whether you want to operate or view only to the right in the picture. In this example, we have taken right into operate, but in the validation handover, you first take it into view mode, and then you get acquainted, and then you do a handover to operate the airport. So now you see that the third airport is being displayed on the heads up and also on the heads down on the upper right side. So now you're operating on 3 aerodromes on this Mrtm. And you also have 3 aerodromes in the dashboard to the right with the EFS, etc. And you can also see the traffic on the 3 different aerodromes. So now the controller has to divide attention between the 3. You can have taxiing aircraft, you can have aircraft taking off and land at the same time on the 3 different. So the human factors, things and aspects come strongly into mind here. When the traffic increased, and hopefully the supervisors who detect that before the traffic becomes too much, then you can split one airport and send it over to another position. And as I said, normally you take it up to view mode on the new controller. The new controller that can then look at the traffic, see the traffic on the heads down. And when the 2 controllers agree, they do a handover and the new controller will take the airport into operations mode. And then it still stays in view mode on the old controller's position. Now we'll show an example on when you swap position of 2 airports. We're going to swap the upper right position, the rest airport, to the lower screens, so that Bodø goes to the upper right again. That's also done. There you saw. Now Bodø is on the upper right screens and the rest on the lower screens. So that could be if you want to use the larger screens to an airport with more traffic, for instance, or a more complex operations at that point. So this is totally dynamic. Now we'll swap it back. We'll see that in a second. It swaps back to the previous setup. There you are. The next example is that after you've handed off an airport to your fellow colleague, then you can close the airport or remove it from your screen. And that is simply done by clicking it out and confirming that you want to stop operating it on your screen. And then this RTM goes back to a 2 aerodrome operations mode, again with the 2 on upper and lower on the side here, and the same on the heads up. So this is totally flexible for the controller, and they can also move the division lines on the heads down between the airports if you need more space on the heads down. Of course, with using a single screen, the space on the heads down screen is important to manage well. That's why we have a very flexible setup on that part. So that shows the platform. Then we'll move over to the validation execution. And you give me a second, I'll give the word to Tristan, and you can start showing that how that was done in Avinor. Tristan.
Thank you very much, Martin. Hi, everybody. Just going to load the presentation. Should come now. So my name is Tristan Blanc-Brud. I'm working as a human factor specialist, both for this SESAR project and for the remote tower project in Avinor. So I will present you how the validation, Avinor Indra's validation was conducted. I will start with a reminder, introduction of the objectives we had for validation. So we had a set of common objectives for both the ADCOs and the supervisors that were agreed among partners of the same validation. So here you can see the different validation objective topics. So workload was one of the topics to validate that workload can be maintained at an acceptable level. Another topic was the situation awareness, that situational awareness also can be, is at a good level in this context. That the HMI also usability and utility is good, so that the design is efficient. Also operating, we have validated that the operating methods to handle multiple aerodrome or supervise multiple aerodrome for the supervisor were efficient. We also evaluated the roles and responsibilities, so that the roles and the responsibilities for both actors, the ADCOs and the supervisor, in this context of multiple operations were acceptable. We had also objective related to the trust in the system, and also we have we could explore an objective to explore transition factors. That is to say, to identify, try to identify training needs or new competence requirements. And last but not least, safety. So to ensure that safety was maintained, that the ADCOs were able to detect, for example, hazardous situation, or to manage that ADCO were able to manage conflicts in that context, and also that both ADCO and supervisor could collaborate efficiently to manage abnormal situations like emergency or technical problem in on a position. The next slide is about the participant. So we had 4 ADCOs. So we had 6 2-day session. 4 ADCOs in total. That was for the SESAR validation, because the SESAR validation is focused on control aerodrome. But we also had validation days with AFISOs, since for Avinor validation purpose, since Avinor is also operating AFIS aerodrome remotely. We had in total 6 supervisors, 2 from ACC, and 4 from big towers. We had 4 simulated aerodromes. So the participant ADCO had was supposed to have endorsement to 4 aerodrome. And we had 2 positions, like Martin showed. So one position was manned by the participant, the ADCO participant, and the other position was manned by an ADCO, a part of the validation team, to play all the handover of aerodrome. Yeah, so to be able to play all the scenarios. And then the supervisor had an extra 11 virtual aerodrome in addition, So a total of 15 aerodrome for the supervisor to monitor. So the schedule for the validation, we had a 2-hour, started with a 2-hour introduction and a 2-hour training. And then we had 5 different runs, each run lasting 1 hour. And then we had at the end of days the debriefing and a final questionnaire. So if we look a bit into detail in the different runs and scenario, each run was focused on a specific topic scenario. So the first run, as you can see, was focused on a merge topic, so merge scenario, so merging aerodrome into the same position. So the Outgo started with 1 aerodrome, then had to open a second one on the same position, and then received a third one that was handed over by another Outgo. So of course the scenario was designed, the traffic level was defined in a way to allow for handling more aerodrome into the position. And you can see on the right column gives you an idea of the traffic level for a maximum simultaneous movement for each run. So the second run was focused on split. So the Outgo participant started with handling 3 aerodromes simultaneously, and the scenario was designed in a way, and the traffic level was defined in a way to expect with traffic exceeding a certain threshold in the future. And so the expectation was that both the supervisor and the Outgo would see the need to split aerodrome, so for the Outgo the need for the Outgo to hand over one of the 3 aerodrome to another Outgo in order to make the workload manageable. The third run was dedicated to a scenario with a technical failure on the position. So the expectation here was that the supervisor will help the Outgo to move to the other position. So the supervisor could prepare also at the means to the tools to also prepare the other position, which means to load, to preload the aerodrome on the new position. So the Outgo just had to move from the position with the technical failure to the new position. And to spice it up, we also added an expected and planned handover of aerodrome due to fake illness of the other Outgo. So the Outgo on the position had to receive a third aerodrome. So it was quite interesting, and the workload in that case was quite important for the operator. The run 4 was dedicated to scenario with an aircraft emergency. The Outgo started with 3 aerodrome. For the aircraft emergency was leading to a diversion of the aircraft in one of the aerodrome. So the expectation was that the supervisor and the Outgo would agree that the Outgo would only keep the aerodrome where the aircraft emergency is handled and hand over the 2 aerodrome to ensure that the emergency situation can be managed. And that's what happened in the validation. The last run was combined tower. It was a run where one of the aerodrome was combined with approach. This is the different various traffic that we had and the different conditions, situations that we had also. So we had some change, of course, and unexpected situation to be able to measure the situational awareness level, for example, or to evaluate the safety objectives. This is an insight in the supervisor's task during the validation. Since this role is quite new, as Martin mentioned, so the task for the supervisor were to monitor the traffic load, especially in the future, to anticipate any potential overload with respect to a cluster capacity, so to a remote tower module capacity. We had for the exercise we defined a rule with rule of 8 maximum simultaneous movement, with VFR counting as 1.5 movement. So that was the rule of thumb for the supervisor. Also to change, of course, the task of the supervisor is to change the allocation of aerodrome when between RTMs and aero operators as necessary, to support the transfer of aerodrome between RTMs, like I mentioned, in case of technical failure in RTM, for example, and also to support operators to manage the unexpected situations. So that was also quite interesting, because in big tower today we have there is a supervisor, but in small tower there is no supervisor. So it's quite important to define the role of the supervisor in that context, and the task sharing between the supervisor and the Outgo in these situations, in unexpected situations in particular. To finish, just presentation of the data collection means. So we had observations during the run, video recording as well, post-run questionnaires just after the run, in particular to assess the workload, the situational awareness for each run, and debriefing, as I mentioned, and also post-exercise questionnaire. So all the results for the different objectives are currently under analysis. They will be presented in a SESAR report, of course, towards towards the end of the year, I think. But I'd be happy to answer questions if any about the preliminary results during the QA sessions. I'm done with the presentation. I will hand over the floor to you, Martin.
Thank you very much, Tristan. Very interesting to hear about that validation. And then we are closing on the last presentation. We will hear from Fanny Kling from Hungaro Control about details from that validation. Fanny, you can start.
Thank you, Martin. Okay, just a minute. Okay, so my name is Fanny Kling. I'm a human factor specialist here at Hungaro Control. Okay, thank you. That's okay. And I'm working on the multiple remote tower project. I've been involved from the wave 1 activities, but back then we haven't really focused on the supervisor position and the flexible allocation. So, so now this was our focus. Csaba already mentioned actually he has shown this slide, that we had a real-time simulation in Ssr last November and December. It took 2 weeks and we had 6 Hungarian ATCOs in total, with 2 groups, so 3 and 3 respectively. And we had 4 Norwegian airports spread across the 2 Mrtms and also 1 supervisor position. And I was actually wondering that maybe I could show you also some of the results because the analysis has been done. So let's take a look at the higher level results in terms of the workload. This is the Bedford workload scale that shows you the workload averages. As you can see, we had 4 different scenarios. The first one was a normal scenario. We also had an LVP and 2 non-nominal scenarios, the monitor failure and also the emergency. And as you can see from the figure on the left-hand side, there are no significant differences between the workload averages, and in every case, the workload levels are within acceptable level. And also on the right-hand side, you can see that I've broken down the results into Mrtms as well, because the experimental manipulations actually happened in Mrtm1. So for instance, you can see that for the scenario 3, Mrtm1 had a significantly higher workload because this is where the monitor failure happened. In terms of the situational awareness, well, the result is very similar. The better, the higher the situational awareness level, the better. And this is what you can see here as well. So no significant differences between the scenarios can be observed, and the situational awareness levels were within acceptable limits. But if we take a more closer look, we also asked the ATCOs that if their workload was high, then what were the contributing factors? And almost unanimously, they said that when they received a new aerodrome, the workload increased just for a few minutes because it took time to build up the situational awareness. And not just in terms of the traffic situation and because they had to coordinate between each other, but also because of the system and the system behavior. Because the thing is that the system, the way it behaved, did not really fit their mental model. And this brings us to the second point, that whenever there was an aerodrome switch, between the Mrtms or even just within the Mrtm, so if the ATCO wanted to swap the positions of the aerodromes, the radar map shifted to a particularly odd position. So sometimes the EFS covered the new position of the radar map. And interestingly, the MAT window remained on the same spot. So this led to confusion and also a temporary loss of situational awareness. So because the system behaved as it did, actually ATCOs preferred to leave everything as it was, and they were pretty reluctant to move the aerodromes within the Mrtm. But in all fairness, it has to be said that the HMI and the system has been tailored to Avinor's needs. So that just goes to show that what works in one setting may not necessarily be applicable in another context of use. So it's very important to also consider the environment in which it will be used and the users who will work with the system. Regarding the split and merge, because this was also, again, something brand new for us, we also asked what caused difficulties during split and merge. So if you take a look on the pie chart, you can see that in most of the cases, the workload remained at acceptable level during the split and merge. But there were some cases, some occurrences when the workload of the ATCOs was pretty high. So the handover process led to some difficulties, and sometimes even the supervisor had to jump in and help out for the ATCOs. But I would say that the split and merge was really, really appreciated. And sometimes, in fact, almost always, ATCOs and the supervisors use this 2x2 aerodrome distribution because that really balanced the workload and it made everything really, really smooth. Okay, so I was thinking that maybe I will not really talk too much about the Outgo HMI because of the time limitation, and we'll just jump right to the supervisor system, given that the supervisor system is really a focus here in this solution. So you can see that on the pie charts that the feedback was really positive. In fact, the supervisor system was highly praised. So I brought you also an extract from the feedback where they claim that the planning tool in the supervisor timeline is the best tool for a supervisor in an environment like this. It is really useful, although it could be a little more accurate. There were some issues with the accuracy, but Outgo's went to the Mrtm and double-checked the traffic and made their decisions based on all the information that they could gather. And it was really nice that the supervisor system actually has shown this this simultaneous movement, and whenever it was above the threshold, which was more than 6, simultaneous movement within the Mrtm, then it turned to red, so it was quite visible that there will be some overload. In fact, you can see here in this next slide that there is this yellow bar that we had also, which indicated the overload periods within the Mrtm. So the supervisor's situational awareness was really supported by this system. So we also asked, what would you say were the biggest challenges as RTC supervisor? And here are the things that appeared most often in the questionnaire. So to stay in my place and not to take part physically in the situation. Maybe bigger distances between the positions and direct phone lines would have solved this issue. And it is true that it actually came up quite frequently that the simulator was really small in the sense that the supervisors and the Mrtms were quite close to each other. So often the supervisor just stood up and went to the Mrtm and observed the traffic and also helped out during the split and merge. The other one was to precisely identify the peaks. I needed to analyze the data provided by the system because the yellow mark periods were not real peaks in most cases. So that's true, there were some accuracy issues, but anyways, the whole system truly supported the work of the supervisors. And also an interesting one is the last one, to make ATCOs understand the need of splitting. I really like this one because some of the ATCOs pointed out that when they controlled in the Mrtm the traffic, and there was a supervisor decision to split, then they felt that it actually hurt their pride because they felt that they could actually continue the work, they could provide still the ATC to the aerodrome, yet the supervisor made this decision. So it was also interesting to hear this from the supervisor point of view. Another system recommendation was that the supervisor position should have a quick access for a view-only radar, visual, and voice function of any airport. In an emergency situation, there will be no time to walk to the Mrtm position, so there should be a way for the supervisor to get as much information as possible about the situation without putting extra workload on the ATCO. So as you can see, there are some recommendations that we gathered from the supervisor and the ATCOs participating in the validation. In terms of the roles and responsibilities, because this is also a very important part of the human factors analysis and also the skills that Tristan mentioned. So there were some feedback. One of them was that the sectorization was a little unusual for our ATCOs, because I don't know whether I've mentioned this, but out of the 6 controllers, 3 of them are also supervisors at Budapest, but this is a medium-sized airport and they don't need to sectorize there. So that was a brand new thing for them to be really good at during the simulation. They also mentioned that the supervisor should be confident in their decision to split and merge, because the supervisor is the one who has the absolute overview of the traffic within the RTC. So he should be the one to make the call to split. And the ATCOs not necessarily need to question this. However, they also pointed out that because the Outgos are the one who manage the handover process, they should be involved and they should have the capacity to do that. So maybe it's very important. I mean, it's very important to find the time and the right time to do the split so that they also have the capacity. And the last one was that for the supervisor position, the roles should be defined because different interaction would be expected from a big center supervisor and from a 2 or 3 airport multi-remote center. And this is actually what we have also shown, that that in this setting, it was more like a smaller RTC, whereas a big center supervisor in a big RTC may have different challenges and may need different skills. And the last slide, I believe, is the safety and split and merge. Unfortunately, Zoltán Moner, my colleague, couldn't be here, but it was really important that when there is an additional aerodrome, the situational awareness is or will be temporarily lost, and workload may increase. So therefore, as I said, it's very important that the timing of the split has to be very well thought out, and it should happen during the periods with lower traffic. Also, we have to provide sufficient time for the receiving Outgo to build up the situational awareness. Another requirement or recommendation that the new aerodrome shall not mix up the layout of the HMI in such a manner that the Outgos lose situational awareness. And also that moving the aerodrome with more traffic can be problematic. So the best was always when we switched the aerodromes with the lower traffic, so that the receiving Outgo didn't have a lot to get accustomed to. Whereas when we moved the bigger aerodromes with more traffic, then it took more time, and the workload was obviously a little higher for the receiving Outgo. Okay, so that was it. Thank you for the attention. And if you have any questions, then I believe that we can come back to this in the Q&A.
Thank you very much, Fanny. That was very good. Then I'll we'll move on to the next part, which is the Q&A session. And we've had a few questions, so we'll start with one. How often had the Outgo, this is about the automatic speech recognition, how often had the Outgo to reject a wrong detected clearance percent? Was there a difference between incoming radio calls and calls by the Outgo? And maybe you could answer that one, Judgy.
Yeah. Yes. So as I briefly mentioned in the chat, that currently the data evaluation is in progress. So no percentage is available at that stage, and because it was a technical validation, we put a bit more focus on how the technology works, and the accept reject manual interaction was a bit like driven by us, less by the traffic. So we several times asked the controller to accept or reject independently of the recognition. So I'm not sure how precise information we can get from the logs, but we have some dedicated sessions when we were focusing only on what happens by the operation. So we have some dedicated logs when we can grab this information. The question is how many of this we will have at the end, but the rest of the validation was more like testing the system, asking the controller to not interact with the system, just let everything accept or just reject, as I said, independently from what happened in the recognition side. So it's not easy really to answer this question. And the other one is what is the difference between incoming radio calls and calls by the Outgo. In this validation, we used only the Outgo radio channel, so we didn't recognize the channel of the pilot. So it means that the difference is that we have data only from the Outgo side. This is a prototype, and this is something very new for us. So that was the very first implementation, and the decision was made to start with this implementation.
Thank you. The next question, also about ASR. Speech recognition in this case is just to get the log of the clearances, right? What happens about rejection of the recon? It's obvious it must learn from its mistake, but what else? And maybe Victor, you could say a few words about that.
Yes, thank you, Martin. Yes, I tried to sum it up in a comment below the question. Yes, and it's partially right, but not completely true that it only transmits the log of the clearances, because an instructional clearance is described by so-called ontology, which has a structure, and to put it simple, the structure begins with a call sign. It has a main clearance part, which is a category, clearance category. We can imagine it that for example a pushback is a different category than takeoff. So we have a call sign, a main command, or a main clearance, and if there is any parameter paired with that clearance, for example, a waypoint or a runway or a parking position, etc. So these are parts of a clearance which are recognized individually. So all these elements has their recognition scores, which shows the probability of successful recognition, and all this bunch of information is transferred to Indra's system to handle and to display on the HMI. If there is a low recognition rate, it's displayed with red. It has a medium one, which turned out to be really acceptable during the validation, and if it's green, then everybody knows it was perfectly recognized.
Okay, thank you. I think we have time for just one more question, and I think Jon Are, maybe this is for you. In terms of percentage, is there an estimate of the total cost reduction with the use of a remote tower system?
Well, that's a very good and very interesting question, of course. First of all, I don't think we should go into our business case module in the meeting here, but what I can say in general is that, of course, establishing remote towers has a cost, absolutely, and especially for the first movers here. There is an upside with the using of remote tower systems, and it comes from scale, and it comes from moving into multiple operation. So I will not say a number in percentage here, but there is a positive business case of it in terms of reaching, in our case, then 15 airports, and with the introduction of the multi. When it comes to the efficiency of the operators, we see that we can have approximately a 40% increase of the efficiency of the operators itself, but it comes with the costs of the technology and investments. So you can't transfer that directly to a business case view. So that might not be as precise answer as one would like to have here, but it is positive, and it lies, as I say, in the scale of it.
Okay, thank you very much. Then we have 1 minute left, and I would just use the opportunity to, at the end here, show you 2 upcoming SSR validations. We'll also be having open days. So in March 2022, we will do another validation with Hungaro Control in another project, PJ02, which is routing and guidance on the ground to look at follow the greens and how procedures on the ground can detect and use conflicts. And that will also be a real-time simulation. And then in April, as was mentioned earlier by Csaba, we will have a validation in Hungary, in Budapest, with Indra camera system installed on 3 different airports, and that will be a passive shadow mode validation. So we will look at real traffic, and the controllers will deal with the real traffic and do that in a passive shadow mode validation. So both these validations will have open days, physical open days, one here in Norway, in Asker, 5th of April, for the routing and guidance, and one open day in Budapest, 3rd of May. So we hope everyone is able to come and see that. So then we thank you very much for this webinar. Thank you for all the presenters. Thank you for all that watched. And yeah, hope to see you again in the next physical event. Bye-bye.